Right, so for today, I will look at all tricks for differentiation. I will begin with differentiating under the root sign. For instance, if I have y is the square root of x, the trick here is to differentiate what sits here, what sits under the root sign, and divide by 2 times the given function. So if I differentiate x, with respect to x I have 1. So my dy dx, differentiate what sits here, I have 1. Divide 2 times the given expression, 2 times square root of x. So my answer is 1 over 2 square root of x. I'll take another example. Let's say y is a big square root, let's say x squared plus x plus 1. So if I need dy dx, or the derivative of y with respect to x, all I need to do, differentiate what is the root sign, that is 2x plus 1, divide by 2 times the given expression. So that's my answer. 2x plus 1, 2 square root x squared plus x plus 1. I'll take other examples and I'll give the trick to make differentiation beautiful. Third example, I'll look at how to make the chain rule easy, like y is x squared plus 1 all to a power, let's say 3. So if I need dy dx for this given expression, all I do is to drop that power. So I bring the 3 down. Now I'll derive what's in the bracket. Find the derivative of what's in the bracket. I have 2x. Keep my bracket, x squared plus 1. Now reduce the power by 1. Then we can simplify the expression. 3 times 2x is 6x. Keep my bracket, x squared plus 1. 3 minus 1 is 2. That is my derivative. Let's pick another example. Let's say y is now 5 times x to the power 3 minus 4 all to the power 3. So if I need dy dx for this expression, once again there is a coefficient, or there's a number here, so I keep that number before I drop my power. Drop my 3. Now derive what's in the bracket. I have 3x squared. Keep my bracket, x squared, x cubed, take 4, reduce the power by 1. Then I can simplify my expression. 5 times 3 is 15, 15 times 3 is 45. So I have 45 x squared, x cubed minus 4, 3 take 1, 2. I'll take more examples. Now I'll take a look at the trick to differentiate log functions, specifically log to base e, or the len function. So if I have y is len of x, if I need dy dx, it's quite simple. The trick says derive what's in the bracket, find the derivative of what's here. So the derivative of x is 1 and divide by what's there. So len x gives 1 over x. So I'll look at when we have len, let's say x squared minus 1. So just as I said earlier, dy dx, just derive what's here. I have 2x, divide by what's there again, x squared minus 1. That's all. Y is another example, log to base e, that is my len. 1 plus x to the power 3. If I need dy dx, again, derive what's in the bracket. I have 3x squared. Divide with 1 plus x3. I'll take more examples. Let's say I have y equals 2 to the power negative x, a number that has a function as a power. If I need dy dx, it says derive what's it here. If I derive negative x, I have negative 1. Put log of the base, ln 2, and keep the function 2 negative x. Can I simplify? Yes, I can do negative 1. For this, I can just write negative 2, then ln of 2. I'll take another example. Let's say y is 10 to the power x squared minus 2. So like I said earlier, my dy dx, derive the power. If I derive this, I have 2x with log of the base, ln of 10, and keep the function 10 x squared minus 2. So my answer is 2x ln 10, then 10 x squared minus 2. Let's take more examples. I'll put some trig functions. Let's say y is sine of x. By standard conventions, if you derive sine x, we have cos x. So y is dy dx is cos of x. I'll take a look at y equals, let's say, sine of 2x. Now the trick. Dy dx says derive what's it here. If I derive 2x, I have 2. Derive sine, we have cosine, keep the function 2x. So my answer is 2 cosine 2x. Let's take another example. Let's say y is 10 sine 5x. So if I need dy dx, there is 10 here, I keep it. Now I derive what's it here, derive 5x, I have 5. Derive sine, I have cosine, keep my function 5x. 10 times 5, 50. Cosine 5x. I'll take the last set of examples. So I'll look at the next trig function. Let's say y is cos x. Anytime we derive cos, we have negative sign. So dy dx, negative sine x. So if I need y is cos of 2x, cosine 2x, then my dy dx, now the trick. Derive this, I have 2. Derive cosine, I have negative sign, so I can put negative and my sign and keep the function. I'll take the last example. Let's say y is 10 cosine of 5x. So my dy dx, I have 10. Derive what's it here, I have 5. Derive cosine is negative and sine, and I keep my 5x. This and this, I have negative 50 sine of 5x. I hope you enjoyed all these tricks. Don't forget to subscribe to the channel as we continue to make math beautiful. Have a good day. Bye.